All right, let's do this. All right, how do I graph some of these? And you'll see some familiar terms from last year that probably maybe you didn't fully understand, but now you will. All right, domain, range, etc. All right, so my first graph, I want you to go to your y equals screen, please. Go to your y equals screen of your graph, and let's type in 4 over x plus 4. All right, 4 over x plus 4. So remember, get your fraction template. 4 over x plus 4. And let's see what this beast looks like. Now, some of you, I don't know when the last time you graphed, but some of you may not have the same graph I have up here because you have different settings because something happened. All right, look, let's all make sure we're all on the same page. If your graph doesn't match mine, looks much, much weirder, hit zoom, please. Hit your zoom button at the top of the calculator and number 6, standard, which will put it back in its default settings. All right, so hit zoom at the top, standard number 6. And we should all be getting this graph. Everyone good? Okay, keep that graph on your calculator because I have some questions for you. All right, let's talk domain. Anything you remember about domain? X. Go ahead, Richie. Those are your x values. All right. Now I need you to look across the x-axis right now and see at every x coordinate you go to that there's a graph above or below it. Because I think there's one point that there is no graph above or below. So here's what I'm saying. I go to this one, there's a graph right there. I go to this one, there's a graph right below it. I go to this one, there's a graph right below it. And it's not all real numbers here. There's one x value up here where there is no graph above or below. So it cannot be in our domain. Can you see that on your graph? Maybe. Or maybe now you know how to go to your table. You know how to go to your table, second graph. Is there a value for x on your table that says, oh, nothing, error, undefined? I don't know what it says, but it says something there. Got something, Emma? Everyone see -4? All right, even go to the graph right now. Take a look at your graph. Look, 1, 2, 3, 4. There's no graph above or below it. All right, so my domain is all x values except for -4. Now, how do I write that? Because I need to write it fancy. Anybody write it fancy last year with your teacher at all? Okay, so here's how I'm going to write it. Your domain, x. You remember this little vertical bar here, maybe? No? Maybe it's such that. I don't know if anybody was exposed to that. This is how I roll. X such that x cannot equal, so the equal sign with the bar. And what was my value, Emma? -4. Cannot equal -4. And I just put these fancy braces. I don't need to see them. You can put brackets if you want, but that's what I do. All right, so any x value except for -4. That's what that's saying. All right, what about range? What's up? There you go. There we go. Range. Now what am I talking about? What am I talking about now? Y values, right? So now go up and down your y-axis. Hey, take a look. Like I take this point up. There's a graph right there. I take this point up. There's a graph right there. I can keep doing this, but I think there's a y value on there that has no graph. No graph at all. There is a y value that has no graph. And you have to use your graph for this. I don't think the table is going to help you. Richie, I think you had a little something there. 0. Look. Take a look, everyone. Everyone see how this graph comes awfully, awfully close, but it will never hit 0 on the y-axis or on the x-axis there. Everyone see that? Okay, so how do I write that now? Take a cue from my domain. What do you think this is going to look like?
Y such that y cannot equal 0.
Boom. There we go. What's that? Such that, yeah. Yeah.
My graph
Table set.
Remember you taught us the such that? You didn't know? Alice? She's been gone for like 2 days. Yeah, she's never gone. Is she okay? No.
Okay, ready? All good? Good enough?
Yeah.
Okay. All right, y-intercept. All right, I'll make this very easy on everyone. That's where the graph crosses the y-axis. And I don't want you to use your graph. I want you to do it algebraically. The y-intercept is when x equals 0. All right, all I'm going to have you guys do to find the y-intercept is take 0, plug it in for x into your equation. All right, so the one I've graphed is 4 over x plus 4. I substitute in a 0 everywhere I see x, and it will tell you what your y-intercept is. So I substituted in 0 for x. Everyone now algebraically find what my y-intercept is. Now when you plug in 0 for x, what's my y-intercept come out to be? 1. So the y-intercept is 0, 1. Now could you go to your table too? Maybe some of you did that. That's fine too. All right, and see when x equals 0. All right, talk to me here. Have you guys ever heard of these two terms here? Asymptote, vertical or horizontal? Okay, you know what a vertical line looks like, right? Okay, a vertical asymptote is a vertical line that I can put on this graph that the graph comes awfully close to, but never will intersect. So this is not a vertical asymptote because it intersects the graph. Okay, I want to put a vertical line somewhere on my graph right now that does not touch the graph, but the graph comes awfully close to touching. And we've already talked about this already. Where can I put that vertical line in? It has something to do with what we've already written. Negative 4, right? 1, 2, 3, 4. I could put that bad boy right here. All right, so what's the equation of that? Anybody remember vertical lines? X equals negative 4. All right, all vertical lines have x equals. And then horizontal, give me a horizontal point where it goes awfully close to but never hits. 0, right? So y equals. So you see some relationship now. Hey, horizontal and range are always related. Vertical and domain, always related. All right. All right, one more time before I take away your calculators. Go ahead. Clear out y1 for me. Clear out y1 and let's graph this bad boy. All right, make sure y1's cleared out. I don't want both graphed at the same time. All right, so for the domain, you can either look at your table or look at the graph and figure out what x coordinate has no graph above or below it. And what do you guys see? Should be 3, right? The domain should be anything but 3. So x such that x cannot equal 3. All right, range isn't 0 anymore because take a look. It hits it right there. But there is another spot on the y-axis where I do not see any graph to the right or left. 2. Yep, everyone see 2? So y such that y cannot equal 2. Good job, good job. Y-intercept now. Substitute in 0 for x. So 0, comma, substitute it in. I would definitely not use the graph for this. Definitely use some algebra. So everywhere you see an x, plug in 0 to find the y-intercept. Getting a fraction. Negative 1/3. Everyone getting that? Okay, now hey, use the relationship we had in the last graph. What's my vertical asymptote associated with? The domain, right? The domain. So my vertical asymptote will be x equals 3. And then my horizontal, y equals 2. All right, ready? All right, let's try to do this a little quicker. No graph anymore. No graph, no graph. You can use your calculator to crunch numbers. All right, but I want to show you how to do this algebraically, no graph. All right, ready? So I have -4 over x minus 2. First thing, domain. Oh, it says what's it? Actually, I don't need to find domain and range here, right? It just says the horizontal and vertical asymptotes, y-intercept, and that's it. All right, so 3 things. Let's do vertical first. Okay, first thing I want to find is the vertical asymptote. I'm just going to abbreviate it V-A. Okay, to find the vertical asymptote without using your graphing calculator, you tell me where this fraction is. I'm going to use a word from this unit, undefined. Anybody want to remind me and your classmates what undefined means again? When does the denominator equal 0? Correct. So off to the side, you can take your denominator. When does the denominator equal 0? If x equals 2. And there you go. There's your vertical asymptote. X equals 2. Where the fraction is undefined will be your vertical asymptote. And this is all up here too. All right, next, let's go y-intercept. That's probably the next easiest one. You guys know how to find that algebraically. What do I need to plug in everywhere I see an x? 0. All right, so go ahead. I'm going to start calling out people here. 0, comma something. $14, going deep there, Isabel. What do you have? What's that? Okay, do you know? Here's what I'm saying. You take x, you take 0 and plug it in for x. And I just want to know what it turns out to be. So here's my, right? How many x's do you see?
1.
Plug in 0 and let me know what all that equals now. All right, so -4 over 0 minus 2. There you go. That's it. There you go, 0, 2. That's it. That's the only way I want you guys to find the y-intercept. Undefined, vertical. Plug in 0 for x, y-intercept. Now, I'm going to slow it down. How do I find the horizontal asymptote without looking at the graph? It depends. Okay? We need to start talking about a word here called degree. In the numerator of number 3, do you see a variable? Anybody see a variable? No. So we say the degree is 0 if there's no variable with an exponent. Oh, good. There's no variable. We say the degree is 0. 0. On the bottom, what do you see? A variable with raised to the what? To the 1. So we'll say the degree is 1. It's the highest exponent showing. That's what a degree is. Great. Good? Degree. Highest exponent showing in each numerator and denominator. So what did we say the degree was in the numerator? There is no variable, so it's 0. What's the degree in the denominator? What's the highest exponent in the denominator? 1. Which one has the higher degree then, numerator or denominator? If the denominator has the highest degree, we automatically say the horizontal asymptote is y equals 0. Okay? So if the denominator has the higher degree, automatically, no questions asked, the horizontal asymptote is y equals 0. Go. Let's go, Grant.
For 4, they're equal.
I'm not there yet. Don't steal my fire. Okay, don't steal my fire. So this is if the denominator has the higher degree. If the numerator had a higher degree, there'd be no horizontal asymptote that exists. It doesn't exist. Okay? Now, what if they're equal? Come on with me to number 4, everybody. Okay, number 4. First, first, can somebody find the vertical asymptote in number 4 without graphing it? When the fraction is undefined. What are you going to set equal to 0 here? Well, x minus 1 equals 0, right? Don't care about the numerator. When is the denominator equal to 0? That means it's undefined. So go ahead, solve for x real quick, and we get x equals 11. I don't have my cheat sheet. Who's got 11? Drew?
What would you ask?
When is this fraction undefined? When x equals
1.
1. And there you go. That's your vertical asymptote. X equals 1. Let's go y-intercept now. Go ahead, find the y-intercept, everyone. We've been doing this a bunch now. 0, comma. Plug it in, plug it in, plug it in. And what's your y-intercept here when you solve that whole thing after plugging in 0? 4? -2, Marty, thank you. Any issues yet? Before I get to, what's up, Max? Go ahead. Okay, so I took 0, and everywhere I saw an x into my equation, I substituted in 0 and just plugged it in my calculator. Okay? Anybody else? Okay, next, last one now. Horizontal asymptote. So the first thing I need to figure out is where's the degree bigger? What's the degree on the numerator? What's the highest exponent? 1. What's it in the denominator? 1. Ooh, what do I do when they're equal now? All right, does everyone see why they're equal before I tell you what to do when they're equal? Okay, I got a 1 here, and the highest exponent here is also 1. So what do? I divide the numbers out in front. So the number out in front of this x is 4, and the number out in front of this x is a 1. So when the degrees are equal, I divide them. So it's going to be y equals 4 divided by 1, 4. So when the degrees are equal, I divide the numbers out in front. So let's go over the rules one more time. Denominator's bigger, y equals 0 automatically. Numerator's bigger, no asymptote. Same, I divide the numbers out in front. So that's really the only complicated thing you have to actually remember for the horizontal asymptote. Questions? I think you want to try, maybe not this one on your own, but here we go.
Do we need to graph it for this one?
No, I do not want you to do any graphs. You should not be, I don't care about the graphs at anything. All right, I just want you to look at it and tell me, ready? Vertical asymptote. You don't care about the numerator, what do you care about? When the denominator is undefined. So what are you going to do? When is x squared minus 1 equal to 0? It's a little bit different because you have to do what to x squared minus 1?
You have to subtract them in square. Or square root.
Ooh, I'm trying to avoid that. What have we been doing all unit? Factor it? Okay. It is, but I'm afraid, though, you're going to forget both answers. You're just going to put 1, and there's actually 2 answers. That's my fear. So that's why I like seeing x plus 1 and x minus 1. So now, how many vertical asymptotes do I have now? 2 of them, right? I have x equals positive 1, and I have x equals negative 1.
You don't have teaching in
Not here today. Not here. Medical, yep. All good? Now look, I'm not going to take your calculator away from you Wednesday on the test. If you forget this and you want to look on your calculator and say, oh, it's here and here, okay, that's fine. All right, I just hope that it's not a fraction and you guys can see it. All right, ready? Y-intercept, go ahead. You guys can find the y-intercept, 0, comma, what here? 0, comma. Remember, everywhere you see an x, you're going to plug in 0. Everywhere you see an x. And what are you coming up with here? 13. Backing up. Is that you, Richie? 13?
Yeah, I got 2.
Yep. 0. You got 2?
Yeah, that's what I got. Is it not 2? Is it not 2?
I don't know. I got everyone else but me has 2, I guess. So I guess it's.
What did you get?
I don't know. I have 0, 1 written down. I don't know where that came from, but 2.
Oh, yeah.
Okay. All right. Better change that for next year, huh? Whew. All right, and then 3. Ready? Horizontal asymptote. What's the degree in the numerator? 4. What's it in the denominator? So if the numerator has the higher degree now, we say there is no horizontal asymptote. None. None exists. Okay, you won't have one every single time. All right, you good? All right, one more with a little shake up, and then you're on your own. Hey, oh, here we go. 3 over x minus 7 minus 8. What do you say we do the vertical asymptote? Actually, you know what? Can we do the y-intercept? Just get that out of the way. What's my y? Let's just get that bad boy out of the way before we start talking lines. Go ahead, y-intercept. Take your 0, plug it in everywhere you see an x. Let's figure out where it's going to cross the y-axis. Is that not a strong note? Little fraction here, kids, huh? Whew, nasty one, too. Good thing I don't have you look at the graph for this one. Getting a fraction here? A negative fraction? It's got a larger number than we are accustomed to. Negative 59 sevenths. Woo! Yep. Correct.
Wait, how'd you get that? Yeah.
Okay, I took 0. I did 3 over 0 minus 7 minus 8 in my calculator.
Oh, I think I forgot the negative.
Got to make sure you got the minus 8 there too, because that's part of it. And also too, worst comes to worst, graph it and look on your table where x equals 0. That's the other way to do it too. All right, everyone all right before I move on, before it gets nuts and I get nuts. All right, before I do anything here, let's mention this here, because usually, here's what I had you deal with all today. Was this right here, right? Well, now I'm throwing this minus 8 at you. And I know you guys did transformations last year, up, down, left, and right. What am I doing to this graph here? If I go minus 8, this whole graph is getting shifted down 8 units. So keep that in mind, please. This is getting shifted down 8 units. So everyone see my red graph here? That's 3 over x minus 7. The blue one is the minus 8 included. Everything's getting shifted down 8. Okay, keep that in mind for the end here. All right, what do you say we do vertical asymptote first? Vertical. Don't, oh, are you kidding me? Right in the middle. Good old technology. You better install all my work there too. We're just on fire there. All right, lucky. Put a hole through this thing. All right, vertical asymptote. Remember, that's when the denominator is undefined, right? So everyone take your denominator, x minus 7, and tell me when that would be undefined. What would I have to plug in for x for me to get 0 in the denominator there? X equals 7, right? So there's your vertical asymptote. X equals 7. Good so far. All right, let me just transition right into this now. You're going to have to find. Remember at the very beginning, what was the vertical asymptote always associated with? The domain or range? Domain, x values, right? So if I know the vertical asymptote is x equals 7, you already now know the domain. All right? Domain will be anything but x such that anything but 7, because I have a vertical asymptote there. No graph. That means the domain can't be there. I don't have an x value there. All right, you ready to finish this beast? Horizontal now. Woo! Now I'm really going to challenge all the studs in here. Horizontal. Now we got to look at the degree. Everyone look at the top. What's the only thing in the numerator here? A 3. Is there any variable? So what do we say the degree is? 0, all right. And then what about in the denominator? What's my degree? 1, all right. Stay with me. So if the denominator has the higher degree, do you remember what the rule was for horizontal?
0.
Y equals 0. Yes, yes, but not here. Hey, y equals 0. What did you just tell me we're doing to this graph? So guess what also gets moved down 8? The horizontal asymptote. All right, see how it was here? And you said move down 8? Sure, that means that's got to move down 8. So it's not going to be y equals 0. It's going to be y equals -8. Now, is anybody thinking, well, why didn't you just do that for the vertical one? Why didn't you move down 8? Whoa, 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 whoa. X equals 7 is a vertical. If I move it down, isn't it going to stay that same line, right? So it doesn't affect the vertical, only affected the horizontal. And then finally, how about the range now? How about the range? If you knew y equals -8 was your horizontal, the range will be anything but -8. All right, these always go together. Vertical asymptote, domain, horizontal, and range always go together. Okay, questions before I let you go? Get started. You got some time here. No graphing. There's no graphing tonight. All right, you either can use your calculator or the rules I have just given you. All right, go ahead. You should at least speed through at least 2 or 3 of these before we get out of here. No graphing. No graphing. There's only 4 problems too. And everyone see the directions? Because it might be different in the textbook. I just want you to find domain, range, y-intercept, vertical, and horizontal asymptote. Don't graph. And hey, what I mean by don't graph is literally don't draw a graph. You can use your graphing calculator. I don't care.